Hello, so today we are going to look at simplifying equations where variables are on both sides of the equation. So when you have variables on both sides, you can actually add or subtract variable terms just like you would add or subtract with numbers by adding or subtracting the coefficients. So 3x plus 3x would equal 6x because you add the two numbers in front, 3 plus 3, to equal 6. So these terms can be added and subtracted just like numbers. And one helpful tip for combining variables is try to combine all variable terms on one side of the equal sign and all numbers on the other so that your equation ends up looking like 3x equals 9, for example. All of your variable terms would be combined on one side of your equal sign and your numbers are on the other so that it's one-step equation to solve. And it's a little bit easier when you're working to combine variable terms on one side of the equation is to look at the coefficient. And it's a little bit easier if in the end your coefficient ends up being a positive number. So for example, if you had 3x plus 4 equals 5x minus 9, if you subtracted 3x on each side, you would end up with a positive variable term because 3x minus 3x is 0, 5x minus 3x is 2x, and that's a positive number versus the other way if you combine like terms and you subtract the 5x from each side, 3x minus 5x, you would end up with a negative 2x. So a positive versus a negative. It's a little bit easier and you're less likely to make mistakes if you can combine variable terms so that it's positive on that side of the equal sign. So let's look at a few examples. In this equation, we have 3x plus 4 equals 2x minus 9. So I'm going to combine my variable terms just like I would numbers. I see there's a 3x here and a 2x here. I could subtract 3x, but then I would have 2 minus 3 and end up with a negative number. So I am actually going to subtract 2x first. So if I subtract 2x, I want to subtract it on both sides of the equation so that it's balanced. And then 3x minus 2x, I just have an x left. And I still have this plus 4, so x plus 4 equals 2x minus 2x. These two cancel off, and I'm left with a negative 9. This subtraction goes with the 9, so it's a negative 9 is what I'm left with. And then to finish solving, there's one step here, the opposite of adding 4, or the inverse operation. I would subtract 4 on each side. These two cancel off. I'm left with just x. So x equals a negative 9 minus 4. X equals a negative 13. And just for good measure, if I check my answer by plugging in negative 13 for x, I would have 3 times a negative 13 plus 4 equal to 2 times a negative 13 minus 9. 3 times a negative 13, that's a negative 39 plus 4 equal to 2 times a negative 13, that's a negative 26. And then I still have minus 9. And last step, if I combine like terms, so a negative 39 plus 4 is a negative 35. And if I have negative 26 minus 9, think of it as adding the opposite. So a negative 26 plus a negative 9 is a negative 35, and it checked out. So our correct answer is x equals a negative 13. Another example, a little bit more complex, you can also combine like terms using your distributive property. So before you add or subtract anything, rewrite your problem after using the distributive property. So 3 times x and then 3 times 5. 3 times x is 3x plus 3 times 5 is 15. and then I have the plus 4x equal to 4 times x, so 4x, and then 4 times a minus 6, or think of it as 4 times a negative 6 is a negative 24. And now I can just combine like terms. So I already see that I have two variable terms on this side. 3x plus 4x is 7x plus 15 equals 4x minus 24. And then continuing to combine like terms, this is a smaller coefficient than this one, so I'm going to subtract off of 4x from each side. 7 minus 4, we have 3x plus 15 equals 4x minus 4x. Those two cancel off, and you're left with a negative 24. Subtract 15, because it's the opposite of adding 15, so I subtract to cancel it off. And we're left with a 3x, because these two cancel off, equaling a negative 24 minus 15. That's the same as negative 24 plus a negative 15, so negative 39. Last step, 3 times something equals negative 39. I'm going to divide by 3 on each side to get x equals a negative 13 for my answer. And you can always go back and check your answer. So if we want to check our answer, you plug in 13 wherever your variable was. So looking here, I plug in negative 13 for x here, here, and here, and simplify. Remember to follow order of operations, so parentheses first, and then multiplying and dividing, and then adding and subtracting. So as you simplify, we end up with negative 76 is equal to negative 76. So I know that x does in fact equal a negative 13 for this equation. So all of these equations that we've worked out so far have had one solution where we've had x equal to one number. It is possible for your equations to have two other options. They could have infinite solutions or no solutions for the equation. So infinite solutions would just mean that it doesn't matter what x is. There's an infinite number of possibilities for x to equal something. X could be any number. No solutions would mean there is no possible value for x that is going to make that equation true. And to know which option is which, as you're simplifying, something is going to happen with the variable. And I'll show you what happens so that you know between infinite solutions and no solutions. So again, we've already looked at one solution equations where you have x equal one number. These two have a slightly different approach. So as we simplify, let's use our distributive property for each of these. So 3x minus 6, because 3 times x is 3x. 3 times a minus 2 is a minus 6, plus 2 times x, that's 2x, plus 2 times 5, that's a positive 10, equal to 5 times x is a 5x, and 5 times 1, so plus 5, and then we still have that plus 1. So let's just combine like terms on each side. Let's keep the two sides of the equation separate. So I have a 3x and a plus 2x. 3x plus 2x, that's 5x. And then I have a minus 6 and a plus 10. A minus 6 plus 10, that's a positive 4. So on the left of my equation right now, I have 5x plus 4. On the right, I would have just one variable term, so 5x and then 5 plus 1, so 5x plus 6. So now with our equation, if you were to finish solving this to combine like terms, you would think to subtract 5x from each side. So if I subtract 5x here, I would have to subtract 5x on this side to keep it balanced. And you'll notice 5x minus 5x cancels off. I'm left with 4. On the right, 5x minus 5x, those cancel off because it equals 0, and I'm left with 6. 4 equals 6 is what I got to. This is not a true statement. These do not actually equal each other. 4 does not ever equal 6. So this is an example of no solution. It doesn't matter what x is, you'll end up with no possible correct answer. So as you're working these out, if your variables subtract off and you end up with a statement that is not true, then it is no solution. In this case, 4 does not ever equal 6, so it's no solution. You could choose any value for x in here. I could say that x equals 3, but as I simplify and work it out, I'm going to end up with a statement that is not true in the end. And you can check it. If you plug in 3 for x and simplify using order of operations, it'll work out to no solution. So let's look at another example. Let's simplify this using order of operations. So let's use our distributive property first for these two. So we're not doing anything on the left. I'm going to leave that as 4x plus 2. And then 2 times x, that's a 2x. 2 times 3 is a positive 6. Plus 2 times x, that's another 2x. And then 2 times a minus 2, that would be a minus 4. So now if we combine like terms, I'm going to keep these two sides separate. There's nothing to combine on the left, but on the right, I could add 2x plus 2x. Look in front of the number, they're both added. 2 plus 2, that's 4x. And then I have a positive 6 and a minus 4. So 6 minus 4 is equal to a 2. Notice these two match already. 4x plus 2 equals 4x plus 2. I can already see that that's a true statement, but if you were to try to finish solving this by subtracting 4x on each side to combine your variable terms, 4x minus 4x, those two cancel off and I have just a 2 at the end. 4x minus 4x, those two cancel off and I just have this 2 at the end. This is a true statement. 2 does equal true, so this is infinite solutions. When your variables cancel all the way off and you end up with a true statement at the end, 2 does equal 2, this is infinite solutions. Notice I don't have variables anymore. It's not saying x equals 10, for example. It's just saying 2 equals 2. My variables canceled off. If you end up with a true statement at the end, it's infinite solutions. So it doesn't matter what value of x you plug in. X could equal 10, x could equal 500, x could equal a negative 13, and you would still end up with the exact same value. It would be a true statement in the end. So infinite solutions mean x is equal to every number. No solutions means x can't equal anything. It won't be a true statement. And again, one solution is just the case where x is equal to exactly one number.